Hello Yr9s, in this video I'm going to go through the prior knowledge assessment that was given to you in the classroom. Watch the video and make the corrections in your own paper in green pen and bring it to the class. So let's have a look at question number 1. So question number 1 is about the atomic structure. The figure below represents the structure of a lithium atom. So the positive signs, I'm going to label this just to make it easy, and you do this in your own paper as well. So these are electrons, orbit or shells. These dark ones are neutrons, and the positively charged particles are the protons. Name the particle in the atom that has a positive charge. That will be the proton. Name the particle in the atom that has the smallest mass. That is the electron. Complete the sentences. The mass number of the lithium atom. The mass number is the total number of particles in the nucleus. So the neutrons and protons are inside the nucleus. So that's 3 positive charges, and which is the proton, and 4 neutrons. So that will be number 7. Calculate the number of neutrons in the lithium atom is. The number of neutron is 4, which don't have a charge. What are lithium atoms with different number of neutrons called? So different number of neutrons. They are not compounds, they are not ions, they are isotopes. An element has 2 isotopes. The table below shows information about the isotopes. Calculate the relative atomic mass of the element using the equation. So AR equals number of mass number, which is, so I'm going to look at this 10 multiplied by the percentage, which is 20 of isotope 1, and then add that to the mass number of isotope 2 and multiply that by the percentage. So 10 times 20, add that to 11 times 80. So let's use a calculator to do this calculation. So 10 times 10 times, oops, why is that not working? There you go. 10 times 20 is 200, and 11 times 80 is 880. When you add that up, it gives you 1080. You have to divide that by 100, and that gives you when you get a fraction like this, you press this number, this button, and you get it in decimal points. 10.8. 10.8. Next question. Calculate the relative formula mass of lead nitrate, which is PbNO3. So relative masses of the Nitrogen is 14, oxygen is 16, lead is 207. So first of all, I'm going to write down the elements which is there. We've got Pb, N and O. Lead is, there's one atom. Nitrogen, because it's in brackets, there's a 1 there. You multiply it by the number which is on the outside, so that gives you 2 nitrogen. Oxygen, 3 times 2, that's a total of 6 oxygen atoms. And then I multiply this by the relative atomic mass of each, so 207, multiply the nitrogen by 14 and multiply the oxygen by 16. So 1 times 207 is 207. 14 times 2 is 28. Now 16 times 6. So let's try that. 16 times 6 gives me 96. Add all of them up. So add 28, add 207. That gives me 331 as the answer. 331. Let's have a look at question number 2. Question number 2. Magnetic forces is a non-contact force. Figure 1 shows a bar magnet. Which letter shows a position where the magnetic field around the bar magnet is strongest? So we have A, B, C or D. Or A, B, C or D. And it's strongest at the poles, but it has to be the closest. So D is closest to the poles. When two magnets are brought close to each other, they exert a force on each other. Describe how two bar magnets can be used to demonstrate a force of attraction and a force of repulsion. So, force of attraction, bring two opposite poles close together. If you bring two opposite poles close together, for example, let's say you have north and south here, and you bring them close to each other, and that will give you force of attraction. How do you demonstrate force of repulsion? Bring two like poles close together. So if I draw two magnets, North Pole and South Pole, North Pole and South Pole, they will repel. Figure 2 shows some paper clips that are attracted to a permanent magnet. Label the north and south poles of the two magnetized piece of paper clips. So you have to label both of them. Because this is south pole, there's a north pole there, which means there's a south pole at this end of the first paper clip. That means there will be a north pole there and a south pole there. Question number 3. Figure shows the forces acting on a skydiver falling through the air at a constant velocity. So you have air resistance and force A. What is the name of force A? Because it's acting downwards, it's not electrostatic force. It would be weight. The skydiver travels downwards at a speed of 56 meters per second for 40 seconds. Calculate the distance traveled during this time. Use the equation distance traveled equals speed multiplied by the time. So the speed is 56 multiplied by 40. That gives me, let's bring up the calculator again. 56 multiplied by 40, that gives me 2240 meters. C. The total mass of the skydiver and the equipment is 85 kilogram. Calculate the weight of the skydiver and equipment. Use the equation weight equals mass, which is 85, multiplied by the gravitational field strength, which is 9.8. So weight is the mass, which is 85, times 9.8. So 85 times 9.8 gives me 833 newtons. Question number 3. Exercise can improve health. A student measured her breathing rate at rest when walking and jogging. Figure 1 shows her results. Let's get rid of the calculator. So, figure 1 is a bar graph where you have at rest. So if you read through there's 5 boxes between 0 and 5. So each box is 2. That means this is 12. The height of that bar is 12. And for walking, it's 24. And for jogging, it's 60. So it's gone up by 12. And it's increased from there to there by 36. And the difference between jogging and rest is from there to there, which is 60 minus 12, that's 48. So these calculations will be useful for the next part, where they're asking A. Compare the breathing rates when doing the 3 different activities. Use values from figure 1 in your answer. So you have to use these values. So if you say at rest it's 12, when walking it's 24, and when jogging 60, right, you'll only get 1 mark. You have to compare each of them. So to get the 3 marks, you have to compare at least 2 of them. So, right, breathing rate doubles or increases by 12, right? So because it went up from 12 to 24, it increased by 12. So breathing rate doubles when walking than at rest. And the next bit, you can compare the jogging to the rest. So how much did it increase by? It increased by 48. So if I divide 60 by 12, you will get 5, right? So breathing rate when jogging is 5 times more compared to rest. To get the third mark, I'm going to compare walking and jogging. So while walking it was 24 and it went up to 60 when they were jogging. So to find how much it increased by, I can work out the difference, which is 36, right? So if I say 60 divided by 24, that gives me about 2.5. Now these calculations, you'll have to do it, or you can say it increased by 36. I'm going to keep it simple. Breathing rate increased by 36 when jogging compared to walking. Explain why the breathing rate changes when doing different activities. Right? 3 marks. To get these 3 marks, you need to write 3 points. Right? Why does the breathing rate increase? The breathing rate changes. The breathing rate is increasing. It increases to supply more oxygen to the muscle cells. Now, why do you need oxygen? O2 or oxygen is needed for aerobic respiration. What is the point of having aerobic respiration? Third point. So that more energy is released. Make sure that you don't say energy is made. You need to say energy is released. Next question. The photograph below shows an athlete using an exercise machine. The machine can be adjusted to vary the rate at which the athlete is required to work. So the athlete's heart rate and breathing rate were measured at different work rates. The table below shows the results in which were obtained. So you got the work rate, heart rate, and the breathing rate. In the next part of the question, they're asking you to plot the data on the graph paper below. So the heart rate they have given you on the y-axis, and the work rate, it goes from 0 to 200. The first thing you need to do is do the scales. The work rate goes from 0 to 200. If you look in the table, from the highest is 200. The heart rate, which should be on the y-axis, goes to a maximum of 175. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I take 20, 40, 60, 80, that's 100 there, and then 120, 140, 160, 180, and then 200 again to the top. And the breathing rate goes to a maximum of 30, so I can say 10, 20, 30, 40. And the question is asking us to plot the data on the graph paper below. So I'm going to plot the points for the heart rate first. When it's 60, which is here, it should be 86. So 60, 86 is 3 boxes up. There you go. The next one is 106 at 80 beats. So that's my 60, 70, 80. I'm going to label this to make it easy. 120, that's 140, and then 160, and then the 200. So at 60, it should be 106. So yes, I made the mistake. 0 is 86. So at 0, it's 86. So that point should be there. Made a mistake. So at 60, it should be 106. So that's 100. 106 is 3 boxes. And then at 80, it should be 112. So halfway point is that. Four boxes in, and then go there. At 100, which is all the way. Let me use something for that. Okay, let's see. At 100, it should be 122. So that's 120, 122 should be there. 120, it should be 135. So 120, 1, 2, 3, 4, 5, that's 130, and then 2.5 box. That should be there. And at 140, it should be 143. So that's 140, 143, and then at 160, it should be 156. So 140, 1, 2, 3, 4, 5, that's 150, 1, 2, 3. And then at 200, it should be 174. So that's, this is 160, 1, 2, 3, 4, 5, Over there. And when you draw a line, you turn the graph paper like this, and then draw a smooth line of curve. You should get the graph which looks like this. So don't worry about the breathing rate. I've just plotted the heart rate. It doesn't say to plot both of them, just one of them is fine. Let's have a look at question number 4. The table below shows the relative mass and charge of particles in an atom. So the relative mass of a neutron is 1, charge is 0. Electron, the relative mass is very small and the charge is -1. Very similar to the first question. The diagram below shows a lithium atom. Give the number of protons, neutrons and electrons. Protons is 3, which is the positive charge. Neutrons is 4, which is the black dots inside the nucleus, and number of electrons is this X, which is 3. Question 5. Figure 1 represents the atom of sulfur. So you have complete the table below. So that's sulfur. That's the mass, relative atomic mass, which is made up of protons and neutrons, which is 36. This is the proton number. Right? So they've said the number of protons is 16. The mass number should both add up to 32. So 32 minus 16, if I take away 16, it will give me 16 as well. Complete the electron configuration. Remember, in the electron configuration, the number of electrons, the first shell for sulfur will be 2, and then 8, and then 6. When you add it up, it will give you 16. So in the first shell, they have given you the 2 electrons. Second shell, I need to add 8 electrons, so I'm adding them in pairs so that it's easy to count. And then for the next one, I need to add 6 electrons, which goes like this. Figure 3 shows the mass of sulfur dioxide in the Earth's atmosphere between 1984 and 2014. A student said the mass of sulfur dioxide in the atmosphere decreased every year between 1984 and 2014. Is the student correct? Well, 1984 is here and then 2014 is there. So it decreased every year between those two times. No, it only decreased from 1990 to 2024. So student is incorrect. You have to use data from figure 3 to justify the answer. So it decreased from 1990 to 2014. Because it's 3 marks, what you need to explain what was happening between those 2 times. So it increased from 1984 to 1987, which is this bit. And then it stayed the same between these 2 years. So it stayed constant between 1987 to 1990. Figure 4 shows the percentage of sulfur dioxide released by human activities. Calculate the percentage of sulfur dioxide released by industry. So we have 69% and 6%. So all of this should add up to 100%. So 100% should be equal to the percentage from industry plus from the transport, which is the 6%, plus from the electricity generation 69. So if I add up 69 plus 6, that gives me 75. So percentage from the industry plus 75 should give me the 100%. So 100 minus 75 gives me 25%. Right? 25%. Now you don't really have to use a equation. If you remember this in your maths, they teach you that a full circle, the entire thing is 100%. So half of that is going to be 50%. So that's quarter, 1/4 of the circle, and that's 25% of the entire circle. That's the end of the questions in your prior knowledge test. Make sure you make the corrections and write down the answers exactly the way I'm showing it to you in green pen. Thank you.